Here are your video notes for lesson 3.8. This is a continuation of notes that you should have taken in class. If I go too fast for you, feel free to pause the video at any time for you to get caught up. But for the most part, what I'm writing down here, you should be writing down on your paper. And these notes are going to be about the distance formula. That's getting covered here because the distance formula is actually related to the Pythagorean theorem. Part of this video will show you how that is. And the distance formula is a complicated looking formula where distance equals the square root of x2 minus x1, that squared, plus y2 minus y1, that answer squared, and you take the square root of all of that after you add it together. And we're going to use the distance formula to find the distance between the points 5, 4 and the points 12, 8. Now if you wanted to, you could get graph paper, graph all this and so forth. Without graphing it, we can just use the distance formula. You will notice these little numbers down here. You have seen those before. I want to make sure you understand how easy these are. The little 2's only really refer to the second point, and this would be point 2. The x-coordinate in the second point is 12, and the y-coordinate in the second point is 8. If we now look at what do these little ones mean, they are only referring you to the first point. And the x-coordinate in the first point is 5. The y-coordinate in the first point is 4. So that's going to help us know where the numbers get substituted in, and I've color-coded it hopefully to make it seem easier. Those little 2's really mean to do, 2's and 1's mean to do no math, although the 2 that's an exponent does. So I'm going to write down this, and now I'm going to take a look at what numbers do I want to put in where. x2 should be the x-coordinate of the second point, which is this 12. So I'm going to move the 2 and the 1 over there, and we'll substitute in 12 there. And the 8 is the y-coordinate of the first point. That's going to get substituted in there. The 5 is the x-coordinate of the first point. I got to grab the top of the 5 to bring it over too. And the y-coordinate of the other point is 4, so I'm going to substitute it in here. And after we get our numbers substituted in, it really becomes a matter of know what math to do next. We would need to take the 12 and subtract 5 first. We will get 7. We still have to square that. We have to take the 8 minus the 4. We would get 4 for that. We still have to square that. We still have to add them together, and we still have to take the square root in order to get the distance. The distance now is equal to the square root of 7 squared is 49, 4 squared is 16. Add these together, we get 65. The distance is not equal to 65. It would be equal to the square root of 65. Using a calculator to approximate the square root of 65, we would get 8.1, and that would be 8.1 units apart. That being our answer. Next part of what I'm going to go over, you do not have to copy down, but I do want to show you how this is related to our Pythagorean theorem. It's related because if I plot the point 5, 4, I'm going out here to 5, up here to 4, and that would be our first point, which I think I used a blue color for. And our second point of 12, 8, 12 is out here twice as far as the 5, and I have to go up here twice as high to get to 8. Here is this point. And how it relates to the Pythagorean theorem, we have found this distance. But when we subtract our numbers that we did right here, the 12 minus the 5, that's really letting us know that the distance across here, let me get rid of that highlighter, I want to go back to having a pen, that's really letting us know that the distance that we have here across the bottom is 7, And when we do the 8 minus the 4 that we did there, that's really getting us the distance that we have right here. Again, I need to go back and get a pen for my drawing. Right here, that's letting me know that this is 4. That's the number we have right there. And if you don't see it yet, the right triangle that we have here is formed right there, where what the Pythagorean theorem would say, if we take the area of the square of the legs, which that square is 49, add it to the area of the square of the other leg, which is 16, that should equal the area of the square that we would build off of the hypotenuse, which is our 65, and to get the length of the side of the square, then this is 65, we would have to take the square root of 65, find out that it's about equal to 8.1. So that's how it relates to the Pythagorean theorem that we've been studying. If we go on, I want to have you in your notes try doing this kind of on your own once. So let's get a black pen again. And for example 2, would you please start off by copying down the distance formula, which says x2 minus x1 squared plus, in parentheses, y2 minus y1 squared, and the square root symbol goes over all that, and use it to find the distance between the points 3, 2 and negative 1, negative 1. Get your numbers substituted in, show your work, pause the video, and when you get done, unpause the video, or if you get stuck, unpause the video, and I'll work through some part of it. You could pause it again. Good luck. Assuming you have got your problem worked out or you're stuck, here's where your numbers should be getting substituted in at. For d equals the square root of x2 minus x1, x2 is negative 1, x1 is 3, so we should have negative 1 minus 3 plus, in parentheses over here, now we're going to take y2, which is negative 1, and subtract from it y1, which is 2. As we go through doing this now, we should get the square root of a negative 4 squared plus a negative 3 squared. Reminder that when you square a negative number, you'll actually get a positive value. So negative 1/4 squared is negative 4 times negative 4 equaling positive 16. Negative 3 squared is negative times a negative and giving you positive 9. So d now equals the square root of 9 plus 16 is 25, and the square root of 25 is 5, so it's 5 units apart. Just to give you a little heads up and hopefully give you some relevance to what you're learning. You might think, where would this ever get used, because coordinate grids aren't everywhere, and I'd like to correct you on that. Coordinate grids are pretty much everywhere. I'm going to get rid of what was written there. But what you're looking at here is just a Google Earth image of the city of Tecumseh. You can see down here it says this is Tecumseh, and it is off of Google Earth. You can see right there. And if you remember the 2 points that we did from back here, the 2 points were 3 and 2, and the negative 1 and negative 1. And if I go back here, let me show you where those are located. You might be wondering, where is our coordinate grid? The coordinate grid for Tecumseh, center of the city is right here. This is the same thing as your y-axis for Tecumseh. To prove it to you, notice if you're on the right side, this is East Logan Street, while anything over on the left side is going to be a West Street. The other axes, which would be the x-axis, is here, and to prove that to you, notice that anything above or north of that axis is a North Street, anything below it is a South. That's a horrible S, but that's what it's supposed to have shown you. So if we kind of locate our 2 points now, quick reminder, it was at 3, 2. If this is 1, this is 2, this is 3, This is 1, this is 2, the 0.32 is right there. Hey, we're right by TMS. So this is the 0.32. The other point that we used was at -1, -1, which is this point. So we have found that the distance from the corner of South Pearl and West Pottawatomie Street to the corner that's out there by the 5th grade loop is 8.1 units apart. If you're wondering what is 8.1 units apart, these units would be blocks. And if the distance of the blocks was, say, 200 feet, we would take 8.1 it wasn't 8.1. I need to erase that. That was the answer to the first one. The answer to this one was, it was 5 blocks. We would be taking the 200 feet that a block is apart and multiply it by 5, and we would know that the distance from here to here is about 1,000 feet. Alright, that concludes your video notes then. You should have written some stuff down with me. I hope you did not try to draw the map of Tecumseh. We'll see you tomorrow.